Okay, working on the homework here for 2.4. We're going to be looking at mostly here product rule and quotient rule. All right, so before I begin, I want to point out that the way I'm going to use product rule and quotient rule is a little bit different than the way the book shows it. And let me explain. If you have two functions being multiplied, so you have a product and you want to know the derivative, the formula I'm going to use is that this should be the derivative of f times g minus the derivative of g times f. I'm sorry, plus the derivative of g times f. Now the way the book does it, if the book says when you have f times g, the derivative is g times the derivative of f plus f times the derivative of g. Now they're the exact same things because we have multiplication here, so that pretty much gives us the same thing. Let me show you now the quotient rule, and I'll explain why I use the red formula instead of the blue. So with quotient rule, the formula that I will use is f prime g minus g prime f all over g squared. And the one the book uses is, let me reference this real quick because I haven't looked at this in a while. I didn't have it open to that page. I apologize. Yeah, what they use is g f prime minus f g prime all over g squared. So you can see our formulas are almost the same, except that they just reverse the order in which they do derivatives compared to mine here, and not reverse the order, they just commute the multiplication, switch the order of the multiplication. So the formulas are very similar. I really don't have a main reason why I do it the way I do it, except for the fact that that's the way I learned it. So it's like automatic for me to do it that way. So throughout here, when I'm working through these problems, just be aware of the fact that I will be using this and this, but they are the same as what's happening there in the blue. Okay, now let's move on to this first problem. First problem, find the derivative of f of x. So what we really have here is, I'll say, instead of using f here, I'm just say this is like a y. And I'm going to say this is my f function and this is my g function, and they're being multiplied. And when they say they want f prime, they really want y prime. So I want the derivative of a product. And therefore, I'll use the product rule, f prime g plus g prime f. Now, f prime is the derivative of f, which is here. And that I can do term by term. So the derivative of 1 is 0. The derivative of 9x squared is 18x. Now that's f prime. Now I need g. G, I don't do anything to it. And then I have plus, get rid of all this here. Okay, plus, now I need g prime, right? So I need derivative of this g up here. Derivative of that is, well, the derivative of x is 1, minus derivative of x squared is 2x. And now I just need to write f next to that. So f was 1 plus 9x squared. So to reiterate, this is f prime, this is g, so times g, plus this is g prime, and this is f. And now all I have to do is simplify this. All right, I actually have the derivative here, but I need to clean it up a little bit. So what I'm going to do, since that's a 0 up here, I'm going to just distribute 18x through here. So we get 18x squared minus 18x cubed. And then for these two, to multiply these two together, I actually have to expand it out. So 1 distributes through. So that plus 1 plus 9x squared. Then distribute my negative 2x through. Negative 2x minus 18x cubed. And now I will try and collect any like terms together. And let me go highest power of x down. So let me get negative 18x cubed. And that takes care of my x cubed term. Now my x squareds, oh wait, hold up, oops. I had another one back here, missed that one. Let me fix that. So negative 18x cubed is negative 36x cubed. So now my x cubes are gone. Okay, I've done those. X squareds, I have 18x squared plus 9x squared. That's going to give me 27x squared. And I've taken care of the x squareds. The only x term I have is minus 2x. And then the only constant I have is 1, so plus 1. So that is my derivative using the product rule. Now that takes care of the first one. It says use the product rule to find the derivative. Now it says perform multiplication first and find the derivative. So what we're going to do is we're going to go back up here. And let me actually multiply this out first. So if I multiply here, I get x. Multiply here, I get negative x squared. Multiply here to here, I get plus 9x cubed. And if I multiply here to here, I get minus 9x to the fourth. Now, if I look at that as being my y, and I say find the derivative, then the derivative of that would be the derivative of each of these terms. So derivative of x is 1, derivative of negative x squared is negative 2x, derivative of 9x cubed is 27x squared, and derivative of negative 9x to the fourth is negative 36x cubed, which, as you can see, matches exactly what I got here, just a different order, but it's the same expression. So you might be saying to yourself, well, wait a minute, that product rule is just way too complicated. Why not just expand everything out and then do the derivative? Well, the problem is that for this problem, yes, I agree. But later on, you won't be able to expand the way you did here, and therefore you'll have to have some other way of getting the derivative. And so the product rule will be the only thing we have. All right, next one. This is a good example right here. Here, find the derivative of this. So again, I'm going to call this y, and that means I want y prime. And I'm only doing that so I can show you that if you split this right down the middle there, there's a product in there, and I can call this first thing over here f, and the second thing over here g. So in other words, my f is actually 3 square root of x, remember, is the same as x to the 1/2, and my g is actually sine x. So remember, the derivative, y prime, should be the derivative of f times g plus derivative of g times f. That's product rule, which for us is the derivative of f. We're going to look at this. We're going to use power rule, so the 1/2 comes out. We get 3/2. Subtract 1, x to the negative 1/2, times g is sine x, plus the derivative of sine x, that's the derivative of g. Derivative of sine x is cosine x, times f, which is 3x to the 1/2. And now the only thing I'm going to do is just kind of clean things up. See if you agree with this. I have 3 sine x. Those are the only two factors that are in the numerator here. All right. And I'm going to drop that x to the bottom. That x to the negative 1/2 is going to go to the bottom. It's going to join the 2 that's down there already. And remember, x to the 1/2. Once it goes down there, it's 1/2, so it'll be positive. And that's just back to this. And then I have plus the other one. Can't really do a whole lot to that. I'm just going to go 3 root x. I'll put it in front of the cosine x. And that is sufficient right there. But again, notice you could not have done what we did up here where we expanded out. Can't do that because there's no expansion possible here. So the only thing we have is the product rule. Okay, so let's differentiate this one. Notice that our variable here is y, so I can't call this side y. You can call it anything you want, really. I just leave it like that and say, what's the derivative of f with respect to y. Well, let me split this where I see a product, which is right here. I see a little f and a little g here. Now notice the f function, I'm going to rewrite it, is y to the negative 2 minus 7y to the negative 4. So I brought the y's up and put their negative exponents. My g function is just y plus 9y cubed. And now I'll need some derivatives. So you might get into a habit of just doing this where you just find the derivatives of these now and then put them all together in a second. So I know I'm going to need f prime, so I may as well get it. It's negative 2y, power comes down, subtract 1 from the power, plus 28 because the negative 7 and negative 4 multiply, subtract 1. And then on the g prime, I just get 1 plus 27y squared. So 3 came out, hit the 9, power came down by 1. So my f prime of y should be, my capital F prime of y should be f prime g plus g prime f, which is negative 2y to the negative 3 plus 28 y to the negative 5 times g is y plus 9y cubed, then plus g prime, which is 1 plus 27y squared, times f. F was y to the negative 2 minus 7y to the negative 4. Now that is what I call the raw derivative right there, but the book won't ever have that as an answer, and this software is going to want you to clean that up also. So what we have to do now is multiply these things out. So since we have multiplication here, I will have to expand like this. So let's do that multiplication. Negative 2y cubed times y. What's happening here is we have y to the first power. So I multiply y to the negative 1, or negative 3 times y to the positive 1. I add those two exponents. Negative 3 plus 1 is negative 2. So I have negative 2 y to the negative 2. Now I do that negative 2y to the negative 3 times 9y cubed. When I add the exponents on the y's, I get negative 3 plus 3, which is 0. Y to the 0 is 1. So we're just going to multiply the numbers. Negative 2 times 9 gives me negative 18. All right, so now what we do is we move here. We do this one times the y. Add the exponents. Plus 28 y to the negative 4, because negative 5 plus 1 is negative 4. And then we have to do 28 times 9, and then add those exponents. Negative 5 plus 3 is negative 2. 28 times 9 gives us 252. So we have 252 y to the negative 2. And that's just the first one multiplied. Now we have to come over here and do this, 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 this. So let me do that there. 1 distributed through just gives me exactly what was there. So negative 2, 1 again, negative 7y to the negative 4. And then now the inside ones. When I do the 27y squared times this right here, add the exponents, we get y to the 0, which is 1. So that just gives me 27 times 1, which is 27. And then when we do 27 y squared here, we're going to have to do 27 times negative 7, which is negative 189. And then we have y squared times y to the negative 4 is y to the negative 2. All right, now let me try and see if I can figure out where my like terms are, because I'm going to start putting all this together. Here's my y to the negative 2. Here's another negative, another y to the negative 2. Here's another y to the negative 2, and here is another negative y to the negative 2. So I just need to add the numbers together. So I take negative 2, I add 252, I add 1, because that's the coefficient in front right here. Right, that's my coefficient. And then I subtract 189. And I think it's 62. So I have 62 y to the negative 2. Now let me look at my, let me get this one while I'm looking at it here. Y to the negative 4 there, negative 7 y to the negative 4. So we take 27 or 28 and we subtract 7, that's 21. So we have plus 21y to the negative 4. And now last we have our constants, negative 18 plus 27. So that should give me 9. So I have plus 9. We can box that up as our answer. Or if you wanted to, you could write that as 62 over y squared. So drop the things with negative exponents down for 21y to the 4th plus 9. I would like to check that and make sure it's okay. $62 and 21, is that right? Yep, there we go. So those are the two possible answers there. Okay, let me grab my calculator because I have a feeling I'm going to need it. Boy, I haven't worked through these homework assignments in a long time. Probably years and years. So it's kind of fun to go through these again. Okay, here we go. All right, next problem. Let me clear some of this out of here. All right, I want to differentiate what we've got here. So first thing you need to notice is that we do not have product rule here. All right, we have sine x. It's being added to something else over here. So I can do these individually, just take the derivative. So the derivative of sine of x is cosine of x, plus the 3/5 is a constant. And now you need to know what the derivative of cotangent of x is. And this is on your formula sheet, but it's also one you want to try and start to remember. It's negative cosecant squared. So negative cosecant squared x is the derivative of cotangent x. And that's being multiplied times negative 3/5. So you just go cosine x. I'll just move the negative in front and make it a subtraction. 3/5 cosecant squared x. We are done. And verify that that's the way they want you to write the answer. I wouldn't think it would have taken that much explanation. Okay, there it is right there. Okay, next one. So now we're going to get on to quotient rule. So remember the quotient rule I'm going to be using is the derivative of a quotient is f prime g minus g prime f all over g squared. So for us, what we need to recognize is we have a quotient, right? We have division, and we have a top function, which is going to be our f, and the bottom function here, which is going to be our g. So I'm going to call f that x plus 2. I'm going to call my g the x cubed plus x minus 3. I know in my formula I'm going to need derivatives of both of those, so I may as well get them now. Derivative of x plus 2 is just 1. The derivative of x cubed is 3x squared. Derivative of x is 1, and derivative of negative 3 is 0. So now it's just a matter of plugging everything into the formula. So I want f prime first, which is 1, times g, so x cubed plus x minus 3, then minus g prime, which we said was 3x squared plus 1, times f, which is x plus 2, and all of that divided by g, which was x cubed plus x minus 3, all of that squared. So I hope you can see, there is f prime, this is g, minus g prime, f, and then here's g, and then you square it. So everything there matches up.